Hi everybody and welcome. In today's video we are going to be talking about trig problems that use the angle of elevation to solve. So your goal after watching today's video will be able to draw a diagram using the angle of elevation and to subsequently calculate the value of any missing side or angle using your diagram with the angle of elevation. So the first thing to start off with is, what is the angle of elevation? So our angle of elevation is defined as the angle formed by the line of sight and the horizontal plane using the ground. So the example of this is if you are standing somewhere and you are looking up at an object. So let's say, I don't know, you look up at the sky and you see an airplane is a classic example. So there is the most beautiful airplane you have ever seen right there. So what this means is your eye looking at the front of this airplane. So if we trace that here, what happens is if you continue to trace this, and let's say that, this is, I'll have to draw the ground first. If we're standing on the ground, and we continue this line here, we trace this all the way to the ground, what we're going to find is our angle of elevation. So I think we just had it measured, but it looks like our angle of elevation, if we have this perfectly tilted here, is 34 degrees. So the angle of elevation is always formed by looking up. So wherever you are, if you continue to trace that line right through your eye, from the ground to the object, that is what forms the actual angle of elevation, which is right there. And the nice thing with triangles, and especially right triangles, is they're formed whenever we see a 90-degree angle. So you can see in the center of the ruler, it's telling us if we draw a line straight down, that's a 90-degree angle. So by doing this, we can highlight the edges in blue. We've identified a right triangle, and we've also identified one of its degrees of measure. Now, the interesting thing about this is if you have a tape measure handy or just any method to measure, what you can do is you can walk along the ground, and you can generally find a measurement for how many feet it takes to get from that point on the ground here to standing directly underneath that object. And as long as you can measure that, you can actually solve for this distance or this distance here. And that's the power of right triangle trigonometry in a real world context. And it's actually a pretty neat thing to do. If you do have a method to solve for your angle, and you can look up at an airplane, you can look at the top of a skyscraper, you can use trigonometry to measure an unmeasurable height. So you could never actually take a tape measure and go from an airplane that's moving all the way down to the ground. But what you can do is by measuring distances and angles, you can exactly calculate what that height is using trigonometry. So that is a very powerful thing that we can often use to solve for those unknown quantities if we're not sure. So if you're looking at like radar or sonar or basically those instruments and they're telling you, okay, this airplane is coming towards you, it's this far away, how do they exactly measure that? One of the methods that they can use behind that programming is trigonometry. So a pretty neat application of how that is there too. A second thing is if you have that measurement app on your phone, that is another way that your phone basically can use to measure some of those unknown quantities, again, using trigonometry to fill in some of those blanks. So we're going to take Scott as our example here. So if Scott's flying a kite, and he's flying this kite above a field, and he knows that he has 65 meters of string. So he can use that length of the string, and he can also estimate his angle of elevation to the kite, and we can see how high above the ground this kite is. So let's start off with this. So let's first draw Scott. And Scott's flying a kite. And we know that this kite is 65. So let's see if we can do this. And second, our angle of elevation is 70, so we should do that to start first. So let's change this very high up in the air, 70 degrees. There we go. Okay, and we said 65, so 1, 2, 3, 4, 5, 6.5. So we'll call that 65 there. And we'll also trace this down to the ground. And then we'll have our plane, our distance here, that helps us out. So there's one option for our plane, and then we can also put where the string starts as a second option for the plane as well. And then we know that this is 70 degrees. And then here is Scott's kite, just flying in the sky. And then we can trace from that string 90 degrees. Exactly down there. There we go. So this makes a triangle. Again, we know that this is a 90-degree angle. So that's one of the things that we can measure. So there's our 65 meters of string. So if we're looking for the distance straight up and straight down from this kite, if we're using 65 degrees of string, and we have the angle, what we're looking for is this side right here. So the angle that we have is our angle of elevation. We see across, that's our opposite side. And then across from a 90-degree angle is our hypotenuse. So we have to look and review our SOHCAHTOA. So sine, cosine, and tangent. And if the two things that we have are the opposite and the hypotenuse, well, it looks like opposite and hypotenuse, we only find those when we're measuring with sine. So let's set that one up. So the sine of our angle is equal to the opposite over the hypotenuse. In this case, we've defined opposite as x, and that's in green. And we've also defined our hypotenuse as 65, and that is in yellow. And inside of our sine function, always, 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 that's where the actual angle goes. So in this case, our 70-degree angle goes there. So from this point, a bunch of different options for solving. I think the most straightforward way, though, is if we use our butterfly method, Wakanda Forever, cross multiplication, whatever you want to call it. We make that x going from side to side. So there is blue. We'll do this one in red. So our blue terms, we have x times 1, or 1x. And then our red terms, we have 65 times the sine of 70. Now remember, that's not 70, that's the sine of 70. So we have to make sure sine and 70 stay married. They stay together forever. So from this point, we actually already have x by itself, so we don't need to move anything else around. We are ready to plug in and solve. And even if you look at this one, you go back to the basics. If we're doing this cross multiplication, let's do object eraser. We can actually see sine is already something that we can solve for here. So something that's arranged easily, even if we don't have our cross multiplication. But cross multiplication, I think, is the most straightforward way. It'll always work when we're going through and solving these things. So time to punch in to our calculator here, 65 times the sine of 70. And just a thing to remember is if we're going through in our settings in our calculator, we always want to make sure we're doing this in degrees. So if you're using Desmos, that little wrench on the corner there, put it into degrees. If you're using a different type of calculator, again, totally fine. Just want to make sure that we are using the correct thing. So 65 times the sine of 70 degrees. And we get our answer there of 61.08. So we can see that the kite from the plane where Scott's hand is, so if Scott's hand is level with his head, we can see that this length here, this x length, is 61.08 feet. Now the key thing is, if from the ground, however tall Scott is, we'd have to add to that 61.08 if it was asking us how far from the ground is it. But in this case, it says how far is the kite above Scott's head. So just above Scott's head, we are 61.08 feet above Scott's head specifically. So that is a method, angle of elevation, a nice real-world application that we can use to solve for some of these. We'll go over different examples of different types of real-world trigonometry, but for today's lesson and today's practice questions, we are specifically focusing on the angle of elevation. Now, one thing that I do want to point out to us is these are not quick questions. There might be a quick calculation at the end, but there is no shortcut to these. We do need to draw a diagram for every single one because sometimes it can be tricky. We're not always using sine. We might use cosine. We might use tangent. The only way to do that is if we actually physically draw out the scenario and physically draw out a triangle. So the expectation for these when we're doing them on a quiz, when we're doing on the practice questions today, is please draw the diagram. So every single question we should see a triangle drawn for it. So as always, thanks for watching. If you got questions, let us know. Let's get started on those practice questions and let's draw some triangle diagrams.